So just remember the principles. When looking at differentiation, you have to be given a function, because the purpose of differentiation is to reduce the function to its derivative. Okay, it's to get something from it. So if I gave you that, f of x equals 2x squared plus 3x plus 10, what would f dashed x be, i.e. the derivative? Okay, so do you still remember the basics in terms of differentiation? Would you be able to differentiate a function, f of x? So f dash x. So what's the first step? Exponent times into the coefficients, right? So what is 2 times 2?
4.
Okay, so write down 4. Then what do? You minus 1 from the exponent. So x squared, that's 2. What's 2 minus 1?
1.
Good. So the derivative of 2x squared would be 4x. Right? Okay, what's the derivative of 3x?
3.
No, not 3. Well, okay, so if we take it the long steps, it would be 3 times x to the 1 minus 1. Do you see that? Okay, if we put in all the steps, then you can see it's 3x to the 1 minus 1, which is x is 0, which is 3. Okay, that's fine. If you want to put the extra step in, you can. You just write down 3, that's okay. Right, does that make sense? Okay, so what happens if you've got a longer term where you cannot differentiate? So next step, on the next slide, you can write this down. Y equals, big bracket, 5x squared minus 7, that's inside the bracket. Close the bracket and then make the whole bracket to the power 9. Okay, so when you have something like that, is it possible to differentiate?
Yeah.
Okay, you're saying yes, but what do I have? I've got a bracket raised by a power, minus 7 to the power 9. Okay, that's what I've got. That's what you've written down, right? Okay, so do you agree? Is it possible to multiply everything out? No, it's going to be very complicated, because how many brackets are you going to have? How many brackets? 9 brackets. Now, can you imagine foiling all of these 9 times? That's insane. Okay, so what are you going to do? You're going to apply chain rule. Okay, so chain rule helps us to differentiate complex functions. That's the purpose, that's the theory. Okay, so let's write that down. Okay, so you've got an example. It's impossible to differentiate that y equals bracket 5x squared minus 7 to the power 9. Because in order to do that, you'd have to multiply everything out 9 times.
So apply chain rule
to get the derivative. Okay, so that's what we're going to be doing with this particular question. Right, so how do I apply chain rule? Well, when you look at the word chain, a chain, think of what a chain looks like. It's like 2 things, 2 metal circles being linked. Okay, so chain rule is exactly that. You're linking 2 expressions. It's linking. Okay, so for the first step, we need to simplify this. It's impossible to differentiate this as is. But if you look at this, 5x squared minus 7, is it possible to differentiate that? Yes, I could differentiate the brackets, but then that's something separate. So what am I going to do? I'm going to use they call it a U substitution. You can use a different variable. U is the most common variable that's used for chain rule. So we say let 5x squared minus 7 equal U. Okay, it could be equal to anything. You could put an x if you wanted to, or a y, it doesn't matter. Okay, no, you couldn't put x because x is already in the function. Okay, so you could use any other variable other than x. You could make it equal to d or a, or u is the more commonly used one when using chain rule. It's what they like to use. Right, so if you've got this, then can I write down the main expression, i.e. this one, in a different way? Yes, I can. I can write down y equals u to the 9. Do you agree? Because I've substituted the bracket in. Does that make sense? Okay. Right, so now I've got two functions, and each function is in inverted commas linked. Okay, so if I've got a function that looks like that, can I derive that function? Yes. Okay, so if I rewrite it this way around, u equals 5x squared minus 7. Okay, that's the function. Can I derive this? Yes, I can. du over dx. Okay, so in other words, the derivative of the u function is equal to 10x to the 1. 10x. Okay, that's the first step. Okay, derive the u substitution. Right, then I've got another expression. So the other expression is this one. There's the other expression. Okay, is it possible to derive a derivative for this one? Yes. Okay, what would it be? Well, this would be dy over du. Okay, so now I'm deriving this expression in terms of u. Does that make sense? See, dy d over du. Okay, I've got y's and I've got u's. So if I'm finding a derivative, what is the derivative of u to the 9? 9u to the 8. Is that okay? Right, so now you've got two derivatives. I've got this derivative and I've got that derivative. Right, what was the original function asking you to find? A derivative. What would the derivative for the original function be? So if I go back to this, had I multiplied these 9 brackets out, I would have gotten y and I would have gotten x. Do you agree? If I wanted to derive this function, the derivative would be denoted by this, dy over dx. dy over dx denotes the derivative for that big function. Okay? Is it possible to still get dy over dx? Yes. Because have a look. Here I've got dy over du. Here I've got du over dx. Does that make sense? Okay, so if I take dy over du and I multiply that by du over dx, it's going to give me the same thing. It's going to give me a derivative. Right, so what is dy over du? 9u to the 8. What is du over dx? 10x. Okay, so if I multiply this out, I'm going to cancel that. And I'm left with dy over dx. Okay, so that's going to be 9. What is u? 5. X squared minus 7 to the power 8 plus, not plus, times 10x. Right, so can I simplify that? Yes, I can. If I multiply 10x into that, I'm going to get a final answer of 90x bracket 5x squared minus 7 to the power 8. And that's the derivative. Okay, dy over dx. Okay, so that's chain rule. That's what you're doing. Okay, you're taking one expression, you're deriving it. You're taking another expression, you're deriving it. And then you're multiplying the two derivatives together, because that derivative, okay, the first one, this derivative multiplied by that derivative gives you the dy over the dx, because you cancel. Okay, and that's what chain rule is. But there are more examples here. They also give you a quotient rule as well, because you can have more advanced functions or more complex functions. Right, so just to add some more rules here. So rule number 1, chain rule. Let's do another example. Y equals square root. Okay, it's a little bit different here because you've got the square root sign, but it's the same thing. Chain rule. Minus 2x. Close brackets. Okay, they want you to find the derivative. Okay, so when we're doing derivatives, remember we said we need to keep it in its simplest form, because I cannot derive a square root. That's impossible. Right, so how can I write the square root in terms of exponents? What does the square root represent? What exponent does the square root represent?
Squared.
Not squared, a half. Okay, so it'll be this. It'll be y equal to that to the power a half. That's what the square root represents. Those two things are exactly the same. Okay, just to recap basics, if I had root x is the same as x to the half. Is that okay? Okay, basics. Great, so now we've got a function that's in the correct format. We've got y equals this. We can see that this is a high level derivative question because you've got a power raised by a power. So this can be linked by using chain rule, and we can therefore say u equals x to the 3 minus 2x. Right, so if that's the function, I need the derivative. Du over dx. Okay, du over dx is the derivative of the function, right? So if I'm working out the derivative, I'm going to have to find what du over dx is, and then I'm going to leave you to do. Okay, can you derive that? What is the derivative of u in terms of x?
So I must derive this.
Derive the x to the 3 minus 2x, yes.
So it's 3x to the 2.
Okay.
Minus 2.
Correct. Good, so now you've got the derivative. All I need to do now is relate that back to what we had earlier. So this y, if I use the u substitution, I can write down this expression as y equals u to the half. Is it possible to derive dy over du? Yes. Okay, what is dy over du? Can you derive that one?
So where's dy over du?
Dy over du.
So where is that? What is it?
That's y. Y equals u to the half.
So is that what I'm deriving?
Yes, because what do we put into the expression? U.
This would be a half.
A half u. What else? What's the rule? The rule says multiply the exponent into the coefficient. Have we done that? Yes. What's the next step?
Minus.
Minus 1 from what? The exponent. So what's the half minus 1? minus a half. Okay, we don't like writing negative a half. That's unusual. So you could write this down as 1 over 2 root u. Do you see that? Okay. Okay, then we need to remember what we had earlier. Let's use black again. If I'm looking at this as the function, y equals square root bracket x to the 3 minus 2x close bracket. Do you agree the derivative for this function would have been dy over dx? Yes? Okay, so is it possible to get this? Yes. I can use this and I can use that. Dy over du times du over dx is going to give me equals dy over dx. And that's what I want. Right, so I'm basically going to take the blue and I'm going to times it by the red. Make sense? Okay, so let's show that on this page. Dy over dx is going to equal, this will be 1 over 2 square root. What was my u? My u was x3 minus 2x. x3 minus 2x. And then times 3x squared minus 2. Minus 2. Right, so we can just simplify that. We can just write that down nicely. So 3x squared minus 2 over 2 square root x to the 3 minus 2x is the derivative, is the dy over dx. Is that right? Still okay. Okay, so I've done 2 with you. I want to give you 1 just to try yourself, but obviously I'll guide you through it. But let's see if you'd be able to. Okay, let's create a sum. Let me create one for you, and you can do it. Okay, it's just another example, e.g. Okay, so I'm going to give you y equals this. X to the 4 plus, I'll keep it simple, 2 to the power 5. Okay. Okay, so the 2 steps, if you're looking at steps, it's quite easy. It's just u substitution. Okay, derive u, and then once you've got the derivative of u, then you can work out the dx. Because it's the dy over du times the du over dx. Okay, so it's kind of like a 2 or 3 step process. Obviously, we need to look at each step separately. Yeah, so first step, good, substitute u in. So u to the 5, that's good.
Obviously, the 2 would just fall away here.
It would. So du over dx, 4x to the 3. Okay, so you got that. That's good. So far, so good. Next step. dy over du. Good. What would that be? Correct. 5u to the 4. Perfect. Last step. Perfect. Okay, you're taking this and you're multiplying it by that. Okay, so dy over dx, let's see what you've got. Correct, 5u. Remember the u you should actually substitute in. So we could put this. You can do it later, that's fine. Or you can do it now, it's up to you. You have to substitute, replace the u. The u you've got at the top of your page. U equals. Good. Times. Correct. Last step. Multiply. Okay, so is it possible to multiply the 5 with the 4? Yes.
But 5 doesn't have a variable and 4 has a variable. How does that work?
It's multiplication. So there's multiplication here. So for example, if I had this 2 times x times 3 times y. Okay, let's just look at that. Okay, so yeah, 2 times x times 3 times y would be 6xy. Do you agree? That's the basics, okay. So this would have been 20x to the 3 brackets x to the 4 plus 2 to the power 4. Do you have the same thing? Mm-hmm. Okay, you're missing a power 4. There we go. Okay, now that's everything. Right, 20x3.
How do you get that power 4? Where was that from?
Where was that from? What was this? There.
Oh, yeah.
Okay, got that. Mm-hmm. Well, that's how you do chain rule. So chain rule is quite a simple technique, but it's very powerful because it helps you to derive derivatives from more complex functions. Okay, that's when you're going to use it. So whenever I get stuck, so for example, if you look at the question that I gave you, y equals brackets x to the 4 plus 2 to the power 5. As soon as you see that, you can already see, ooh, higher level, more complicated function. It's impossible to derive as is. I need to apply chain rule in order to derive it. Mm-hmm. Right, perfect. So then the last bit of this section, and we've covered it, they've given you derivatives for the other scenarios. Okay, so you can put two separate headings here. The one is called product rule, the one is called quotient rule. It's just looking at derivatives relating to two functions being multiplied together. Okay, so heading, product rule, chain rule. Not product rule, chain rule, product rule, quotient rule. Okay, so let's first look at the product rule. Okay, when you see the word product, what does that represent? Multiplication, exactly. Right, so if you have a function like this, remember with derivatives you always have functions and you're trying to get derivatives. So the function is y equals ab. What does that represent? It represents one function but two variables. And are those variables being multiplied? Yes, they are. So is it possible to derive each variable separately? And the answer is yes, you can. Okay, so if I'm looking for the a and the b, but remember, this could have been two separate workings. It could have been a more complicated question relating to the derivative. So would it be possible to derive the one and then derive the other? Yes, it would. Okay, so if I'm looking at the function, this is the function. So the derivative would be dy, okay, over dx. And dy over dx would be equal to, okay, the a d b over dx plus, then you've got the b multiplied by the dA over the dx. Okay, so that's the quotient rule. The quotient rule says when you've got product rule, sorry. When you've got the two products, okay, the one multiplied by the other, you've got what? Products that you can use to find the derivative. So it's possible to derive the one in relation to the other. Okay, this is a technique. The technique can help us when we're doing more complicated questions like this one. You'll see what I mean when I show you an example. Okay, so let's apply that to this example. It's a nice short one. Y equals x squared times square root x minus 5. Okay, so do you agree I've got a square root and I've got a term outside? That means I've got 1. So if I highlight this, this represents the A. This represents the B. Okay, you've got two separate terms. Okay, so the only reason why you use product here, yeah, that's an example. The only reason why I use product rule here is because of the sign, product rule. Let's highlight that as well. See that? That's telling you to use product rule. Okay, because it's multiplication, not adding. Okay, if it was adding, then I could do it normally. But I can't because I've got multiplication. Do you agree? Normally I could have multiplied this out. So for example, I just want to show you some context. What happens if I had this? Y equals 5 times bracket x squared to the 3. Okay, would I have to use product rule here? No, I wouldn't, because I've got 5 and I've got 1x. Product rule only applies when you've got x here and you've got x there and you're multiplying. Because this I can simplify. Do you agree? This will be 5 times what? x to the 6. And then that'll be 5x to the 6. Can I find the derivative of this? Yes, dy over dx would equal 30x to the 5. Does that make sense? Okay, so is it necessary to use product rule here? No, because I don't have x there and x there. So I have to have two different, variables with two different expressions on both sides in order to use product rule. Right, so let's apply it. So then the next line would be dy over dx, this formula there, just write that down. So dy over dx equals. Okay, so they want us to apply this. There's the first part. I'm going to use two colors to do this so you can see it. This is red. Okay, this is the first one. And that needs to apply to that. Okay, so I write down the a. What was my a? X squared. Okay, then they say db over dx. That means I must derive the b. So what is the b? Here's the b. There's it. Okay, the x minus 5. Right, so if I derive that, I'm going to get a half. Okay, because remember, I can write this down as this. X to the minus 5 to the half. Okay, so I can find the derivative of that. What do we do? Half into it. Okay, minus half. Okay, because that's the derivative with chain rule. So I would be left with a half brackets x minus 5 to the power negative a half. That's the first part. See, that's the red, but that's that part there.
But don't you have to do this into there? I don't understand.
Okay, so what is A? That's A. Yeah. What is this? Derivative of B in terms of X. What is B? That. So this is the same as X minus 5 to the half. So if I want this derivative of B, that's the derivative of B. Yes, I am doing this. But I'm just relating it to the question. That's A, that's B. That's A, that's B.
Where's the fraction?
Where's the fraction? dB over dx is what? Derivative of B in terms of x.
So where is that?
There's the B. What is the derivative of B? See, here's the B. This is B. So you need derivative of B over derivative of x. In terms of x. So that is what I wrote there. Right, because the question, the product rule stays the same. So the blue doesn't change. Okay, the blue is the blue. The blue is the rule. Okay, I'm just applying the rule to a different question. Okay, so the rule said, write down the A, which I did, and then the rule
but
said...
I'm just saying, isn't that the formula that you must put it in? Because I don't see this. Yeah, it's different.
You don't see what there? dB over dx. This isn't a fraction. A fraction has numbers. This is a derivative. Yeah. Okay, so do you agree dB over dx is what? Derivative. So what does that mean? This means derive b in terms of x. So where is the expression for b? You wrote it down. B equals x minus 5 to the half. Okay, so that's the b. In order to get this dB over dx, I need to derive that function. Okay, the b.
Okay.
Okay, so now what does this say? Second part. Write down the b, and then it says dA over dx. dA over dx is not a fraction. dA over dx is what? A derivative. Okay, it's saying derive a in terms of x. So where is a? A is there. What is a in this question?
The x minus 5.
The x squared. The a in this question. It's highlighted. There's the a, there's the a. Okay, so how am I going to derive the a in terms of the x? Well, what is the derivative of 2x? Derivative of 2x? Well, derivative of x squared, I gave you the answer, is 2x. Right. Okay, so you've got this part, that's the red part. Let's put a red bracket around it, just to differentiate. That's the red part, that's the red square. Okay, now we've dealt with the red square. The rule says add, and then let's do the purple square. Okay, so purple square, in order to get purple square, I need to write down the b. Okay, what is the b? Root x minus 5. Root x minus 5. Okay, what does the rule say? Write down the b and times it by the derivative of a in terms of x. So where is my a? There's my a, x squared. Okay, so what is the derivative of x squared? 2x. So multiply by 2x. That's it. Okay, the last step is just to write that down meter. So that's just using basic algebra. Okay, the rules for that. Now I'm going to take this whole thing. I'm going to take this red box plus this purple box. So this with the minus a half means denominator. So it'll be a half, so it'll be 2 square roots x minus 5. So this would be x squared. Okay, over 2 square roots x minus 5. Okay, that's the first part. And then you would add the second part. So my second part was that. That stays the same. You can't simplify that anymore. Okay, so it'll be 2x times the brackets. Well, the root is the bracket. Similar. Okay, and that is the dy over the dx. Okay, so chain rule only applies if you've got two variables and you've got two expressions that are being multiplied. The product rule. Okay, product means multiply. Okay, you might be able to, you might have both product rule and chain rule all in one. Okay, that's going to take it to a whole another level in terms of doing one step first, then doing another. Okay, it just depends how complicated the derivative is. Let's see if they give you that in assignment 6. Yeah, they do. Okay, assignment 6 they give you derivatives, but this is the key 10 and yeah, okay, and we haven't looked at yet. Okay. Right, that's the first one, that's the first rule. Okay, new page if you want to. New rule, quotient rule. The last rule relates into this. And then you've just got some basics, derivatives for e and x, ln. Okay, so let's start a new page and let's write down quotient now. Quotient rule. Okay, so again, the rule actually helps you with the actual understanding. When you see the word quotient, quotient means division. Okay, one divided by another. So the rule, this is the rule that we need to learn. Y equals. Let's use u and v. Okay, so u and v. So if you have an expression, that's the expression, that's the function. Just write that down. Okay, that's the function. How do I get from function to derivative? We need to use this rule. Okay, so to get the derivative with the quotient rule is just a specific process. The rule is dy over dx is equal to Okay, so v times du over dx. Okay, so the derivative of the 1 times the expression minus the derivative of u of v times u all over v squared. Okay, that's the formula. Okay, so that's quotient rule. That's how you would apply it. Okay, so the example, let's use the shorter one, not the longer one. Okay, so e.g., we were given an expression, and the expression is in the format of the C function. Right, so the given function is y equals 2x minus 3 divided by x squared plus 5x. Okay, so 2x minus 3 over x squared plus 5x. Do you agree this is impossible to differentiate using normal derivatives? I cannot differentiate something that looks like this. Okay, and I cannot simplify this any further. The reason why you're using quotient rule here is because it's not like this. What happens if I gave you something that looked like this? Let's just show you. X squared, or let's say x to the 6 divided by x to the 2. Okay, would I use quotient rule for something that looks like this? Definitely not. Why? I can simplify. X to the 6 divided by x to the 2 is x6 minus x2, so it's x4. Do you agree? Can I find the derivative of this? Very easily. dy over dx is 4x to the 3. Does that make sense? Okay, so I'm not going to overcomplicate a simple question. Okay, that's a simple question. There's no need to use quotient rule because it's overcomplicating a basic example, because you can find the derivative quite easily. When does quotient rule apply? When I have something like that. Okay, I cannot derive that function as is. Okay, so that's what we need to look at. So let's show the workings. Right, so how do I get the derivative? Well, the derivative says v times the derivative of u. Okay, so let's see. What is my v and my u in this question? What is my u in this question? What is u? The numerator. So what is u? 2x minus 3. What is v in this question? The denominator. Does that make sense? Okay, it's just relating it to the simple equation. Okay, the formula. That's why what I've written here in black and blue, I don't change. Okay, that's the rule. That's the almost like an identity. Okay, what you're using. Okay, so I need to apply the rule. That's all. Okay, so in order to apply the rule, I need to look at what I've been given. Okay, so what have I been given? Well, u and v. dy over dx, in terms of the rule, is going to equal. Okay, let's write down the easy bit. Let's write down the v squared. What is v squared? X squared plus 5x squared. Okay, that's the rule. I've written that down. Okay, then I just need the numerator. What does the numerator say? Well, the numerator says, for my first expression, so for this, let's use a different color. Okay, for this, what must I do? I need to take my v. What is my v? X squared plus 5x. That's my v. And I need to multiply that by du over dx. du over dx is not a fraction, eh? du over dx is the derivative of u in terms of x. So what is my u? Here, that's my u. What is the derivative of 2x minus 3? Derivative of 2x minus 3? The 3 falls away. Derivative of 2x? 2. There we go. Times 2. Right, then minus, subtract. Okay, let's do the other one in a different color. Not too many colors to choose from. Let's use this one. Okay, so this now. Okay, I'll give you a chance to catch up.
This one?
Okay. Right, so what is this thing? Well, the rule says I need to subtract u. What is u? 2x minus 3. That's u. Then I need to multiply that by the du over dx. du over dx is representing a derivative of v in terms of x. Where is v? Here's v. What is the derivative of x squared plus 5x? What would that derivative be?
Of what?
What is the derivative of v?
2.
2x.
Plus 5.
Good. There we go. Close brackets. Right, and that's it. You've applied the rule. Okay, then you can take it further. You can multiply everything out. You can simplify. But that's how you apply the rule. Okay, I'm just going to write that step next. We're not going to look at it. It's a bit too much. Okay, well, we can write on the final answer. Simplify. Simplify. Okay, I'm just going to write down the textbook reference here. Page 70. Okay, work program, WP. Right, you can just write down that final answer here, this one. Okay, so you see that's all the simplifying, that's algebra. Multiply the brackets out, do the minus and the plus. Okay, that you should be able to do. Just write that last bit. Equals that. Okay, that's the last answer. Okay, getting from there to there is just algebra. That shouldn't be a problem because there's no rule there, it's just multiply outs. Okay. Right, and the last bit is just a little bit of these like rules in terms of what is E and then what is the derivative, what is E, what is the derivative, and then we've finished that section. They've given you a lot of additional examples here that you could actually make use of. Here at the end, they've given you trig differentiation. See, but trig differentiation only came now. It didn't come in a previous activity, but it has now, so we can mention it. So the last bit is we just need to write down rules and then be done with this section. These are all examples relating to what we've covered so far. Okay, we'll look at them in the actual assignment. Right. Okay, so let's just end off this section, this bit. The last bit is just rules. You can just put a big heading rules or other rules. It's looking at logs and it's looking at trig. Okay, so the first set, derivatives of E, x and log E to the x. Okay, so I think this I'm going to write down rather as derivative of E to the power x and log E or ln. Okay, let's keep all those workings. Okay, so let's write them down. Can I do equations here? It might be easier to do it in Word. Okay. I think let's just write them down, it'll be easier. I don't want to make formulas now, it's going to take too long. Okay. Alright, so derivatives of e to the x and ln. ln x. Okay, just basics. Ln x is the same as this, log base e x. So we looked at logs not too long ago. That's what we're looking at. Okay, so we're just looking at derivatives of those things. That's all. Right, so they've given you how many? 1, 2, 3, 4. 4 rules to apply to this scenario. Again, these unfortunately you just need to study. It's like trig. Okay, what is sine equal to? What is cos equal to? What is tan equal to? Okay, that's just rules. There is no other way to derive this other than just remembering it. Okay, so the first rule, number 1, let's label them. When I have a function, okay, functions are on the left, derivatives are on the right because of the notation. Okay, that should be okay. Right, so if I've been given y equals e to the x, okay, that's a nice one because look at the derivative, it's exactly the same. Okay, so if I wanted dy over dx, which is the derivative is exactly the same, e to the x. See, that's a nice one. That you don't really have to study because it's the same. Okay, you just need to remember that when I have e to the x, if I have a function, the derivative is the same. Do you want to write those notes? Function e to the x, same derivative. Like a study note.
Okay.
Maybe. You can just say function e to the x, then derivative, the same. Because the maths looks complicated because you've got all these variables and exponents and all of that. But ultimately, what is it saying? It's saying exactly what we just mentioned. Okay, when you have a function e to the x, the derivative is exactly the same. Right, when you have ln, so now if the function is this, so second scenario, y equals ln x. Okay, when I have ln x, if I wanted the derivative, which is dy over dx, then I need to remember that I need to write down 1 over x. Okay, so if you were given a question, let me just show you how to actually use this, just as a side note. If I have this, let's say y equals ln, let's say 10x. Okay, if I had that, what would dy over dx be? It'll be 1 over 10x, do you agree? That's all. Okay, it's just writing down this in that format, that's all. And that's how you get the derivative. See, is it possible to derive this, ln 10x? No. Okay, the only way we can derive ln 10x is if we have a rule. Okay, that's what we need to follow. Okay. Right, let's write down the last 3. Okay, so now here you've got k's. K's are constants. K could have been any number. Number 3. When I have a function that looks like this, y equals ln kx. Then I've got y equals ln k plus ln x. So dy over dx equals 1 over x. Oh, it's the same thing. Yeah, see? Same thing. Ultimately, you get 1 over x, so it's the same. So y equals ln x, y equals ln kx. If you look at that step, it's ln k plus ln x, which is the same as that. Dy over dx, which is 0 plus 1 over x. So it's actually 1 over x. That's easy. We can just write down the final answer of this. Dy over dx for this one also equals 1 over x. Okay, so if we look at that rule, I actually need to fix my example. Okay, earlier on I gave you this example, ln 10x. Do you agree, what would ln 10x be as a derivative? This needs to go. It would just be 1 over x as well. Okay, so you see that? Alright, so I made a mistake with that in terms of application because we have this rule. Okay, this rule tells us it doesn't matter what constant we have in front of x, the derivative will always be 1 over x. So I can study that. Okay, so those two are actually exactly the same. That's from function to derivative. That's from function to derivative. Okay, then the last one, let's just look at the final answers of that, this and that, instead of the middle step. The middle step is just the working. Okay, the last one that we need to study is this. When I have y equals k ln x. Okay, so now the k is outside the ln, meaning it's a constant. The answer is going to be, in terms of the derivative, dy over dx is going to be k times 1 over x. And that's the rule. Okay, then we just need to apply those things. Right, so those are the 4 that you need to study. Got them? Perfect. Anything else you need there? Okay. Alright, so that's just a little bit of studying. And then the last bit is just the trick ones that we also need to write down, and then we're done. Okay, the rest are examples. Yeah, chain rule examples, trig example, derivative. Okay, so we literally just need this, and then we've got everything that we need to study for derivatives. Okay, this is the advanced of the simple, okay, the derivatives. Right, so here, sine, cos, tan, sec, cot, sec, cosec, that's the function. Those are functions, those are derivatives, that's all. Okay, so if I wanted to get from the function to the derivative, I need to apply that. Okay. Right, this one I can write down as a table, so I'm going to save our notes here. Let's draw a nice table, and let's show the last bit, and we're done. Okay. How many? 2, 4, 6, 7. Okay, so function, derivative. Okay, so if I'm given a function sine x, cos x, tan x, sec x, cot x, and cosec x. Right, so if I see any of these in a question, okay, in a simplified question or a solved for question, right, if I wanted the derivative of sine x is cos x. Okay, that's a nice easy one. Derivative of cos x is minus sine x, so it's a negative, not a positive. The derivative of tan is sec squared. Okay, that's a different one. Sec to the power 2 x. Okay, then sec will be sec x tan x, so sec x tan x. And then we've got 2 more. Cot is cosec squared x. Okay, so that one is cot is cosec negative. Okay, negative cosec squared x, great. And then the last one, if I have cosec as a function, in order to get a derivative, I'm going to have minus cosec x cot y. Cot, no, cot x. Cot cot x. Okay, there we go. Right, those are the ones that we need to learn. What would these be? These would be trig functions and derivatives. Okay, that's when I'll use this. So if I'm ever faced with a question where I have tan, cos, whatever, I need to then apply that. Okay, another section completes.